Welcome to the Calculus Building. My name is Gregory Carlson. So let's actually talk about some really important definitions. We're going to look at the definition of a left-hand limit, a right-hand limit, and the definition of limit. So what is a left-hand limit? Remember in the previous video when we had the two friends approaching the ledge to jump into the pile of leaves and they were approaching from different directions? That's what's happening here. Now, by the way, before I do this, these words and the word limit have very formal definitions that are quite complicated, and I'm not going to give you the complicated definition. I'm going to give us kind of a beginner definition because we don't need to get too complicated right now. So what is a left-handed limit? A left-handed limit is, I'm going to call it a value that a function approaches from the left. So that's pretty easy. It's a value that a function approaches from the left, but it's actually a little better to think of it as we're approaching from the negative side. That makes it a little easier, I think, to remember. Because as you know, on our number line, the negative values are on the left, so we're approaching this value from the negative side, from the left side. So the way you write it is this. You write the letters L-I-M, X, and then a little arrow, and then that's going to approach some value. So it's L-I-M, X approaching A. You should remember from your previous math class that in a function, X is when things are happening. X is how we tell when things are happening. Y is what is happening at that X. So we're approaching this value, and we're approaching it from the negative side. So I'm going to put a little minus above the A. That doesn't mean A is negative. It means we're approaching it from the negative side. And we're taking the limit of this function, and that limit is equal to L. And I'm going to call it L sub L, since that's our left-handed limit. So we're approaching from the negative side for our function, and that's going to equal some value that we're approaching, L sub L. So what do you think the definition of a right-handed limit is? You got it. Once again, it's a value that a function approaches from the right. And again, it's helpful to think of it as from the positive side. So a right-handed limit is a value that a function approaches from the right or from the positive side. And so the way we would write that is L-I-M, X approaches, a little arrow, and again, some value, which we'll call A, and this time we just put a little plus there to say that we're approaching from the positive side. And I'm going to call that L sub R, which represents our right-handed limit. So we now have a left-handed limit, we're approaching from the negative side. We have a right-handed limit, we're approaching from the positive side. So what is the definition of a limit? This is a really, really important definition. You need to know all of these, but especially you need to know the definition of the limit. I'm going to say that a limit exists when the right hand and left hand limits approach the same value. So a limit exists, and I should say a limit exists at A. So at a value. A limit exists at a value when the right hand and the left hand limits approach the same value. So if the two limits come together to the same place, then that means that one point has a limit. So in other words, if you want to think of it symbolically, if the limit that we're approaching from the left hand side is equal to the limits that we're approaching from the right-hand side. If those two limits are equal, then we say that a limit exists at the value a. And so in other words, this would equal the regular old limit as we approach that value. So if the left-hand limit and the right-hand limit approach the same value, then we say that the limit exists at that value a, and it's equal to whatever value it is that they're approaching. So I know that's a lot of words. Let's actually look at an example in the next video so you can see what I'm talking about.